Hello everyone, this video is going to go over minting NFTs on Algorand in Python. Specifically, we're going to follow the ARC69 standard for this video. The next video after this one will follow the ARC19 standard, so you can have a bit of variation. But the next smart contract that we write will only feature ARC69 standard NFTs. So if you're primarily here to learn smart contracts, you can watch this video if you don't want to learn both standards, and you'll be good to watch the next smart contract video. However, I would recommend you learn both standards because the ARC19 that we don't use in the smart contract is more recent and has some added flexibility. So for example, the ARC69 standard, when you select an image for the NFT, you input it into the URL field parameter of an asset creation transaction. The URL field is immutable, meaning it cannot be changed. So once you set an image for your NFT, it is stuck that way forever. The ARC19 standard allows you to change the image as many times as you'd like. And also for the ARC69, the other caveat, the length of the metadata is limited to 1 kilobyte because it uses the note field in asset configuration transactions to adjust the metadata, whereas in the ARC19 standard, it doesn't use the note field. It uses a reserve address which points to an IPFS hash on Pinata or wherever you're storing your metadata, and that bypasses this limitation that the ARC69 standard has. So I would recommend you learn both. One's a little bit more complex. This one's a little bit simpler. But regardless, the smart contract that we write with the ARC69, it's going to be a Pokemon-esque contract. Basically, the user will pay the contract will mint a starter Pokemon and dispense it to the user. And afterwards, the user has the option to send the NFT back to the contract to stake it, or perhaps send it to training. And what happens is, as time goes on and the NFT is out of the user's wallet and with the contract, the Pokemon will gain experience and perhaps level up a few times. So that's going to be the next contract we write, and this video will go over ARC69. Something else I wanted to add. So we should probably have an understanding of what metadata is before we get into this. So metadata is information about the NFT that is in context to the actual NFT, but it's like separate information. For example, if you have a Charmander NFT, you have an image of the Charmander Pokemon, you might want to add details or metadata to that Pokemon, like the Pokemon's level, the Pokemon's experience, the type. So it's a fire type, maybe a description, a Pokemon with a long fiery tail. So all this extra information that provides context to the NFT, this would be considered metadata. So the first thing that we're going to need is to go to the internet, go to pinata.cloud, click Get Started. You'll get onto this page here, type in your email. You can use a fake first and last name if you want, even a burner email, create a password. Once you sign in, you should see something like this, and you're going to click New Key, select Admin, and then type in a key name, so I'll just say my key, and click Generate API Key, and we're going to take all of these three things and use it for our code. So an API key, an API secret, and a JWT. So I know there are going to be some people who are not following the tutorial series and just want to watch this video or the ARC19 video. So if you would like, you can watch the installation video for a bit of a more handheld experience for installation, but you will need Visual Studio Code, Python, IntelliSense, which you get through this extensions tab here. Python, obviously, which you get from python.org, install the latest version, add exe to path, and then the imports I'll go over now, so I'll just create a file called minter.py with the paper and plus icon to create a new file. We'll need to establish a client. And this you can get by using pip install py-algorand-sdk. We also will need to import wait for confirmation and an asset config transaction. That's a part of the previous SDK we just installed. From .env, import load.env, so we can load private variables. This you would install with pip install python-env. And then as well, we will need Pinata, if we're using Pinata. from Pinata import capital P Pinata, and this is installed with pip install Pinata. That's pretty much it for pip installations, and everything else. Let's see, we need to convert our private key to an address. And then we'll also need OS, we'll need JSON, and I think that should be it. So to start off, we're going to load our .env, and we're going to create our .env over here. So new file, .env, and we're going to create our variables for these keys up here. So first thing is the API key. So we'll copy this, go back to our code, and write API key is equal to, and paste in that key. Same thing for the API secret. API secret is equal to, and then our JWT, copy that, and it's going to be super long. We'll just paste that in here. And then for our Algod token and Algod server, we can get this information from nodely.io. Just close some of these. And we're going to click Quick Start. And down here, second row for testnet, which we're using, and second column for the Algod, not indexer. We're going to copy this link here. And go back to our code, place it under Algod server, and token you can leave empty because this public API doesn't require a token. Back to our minter, let's import everything. So let's go in order. So our Pinata API key is equal to os.getEnv, and pass in the name of our key here. I named mine API underscore key. That's going to be how I list it here. Pinata secret is equal to os.getEnv, and I named mine API secret, and I'll change this to Pinata API secret. And Pinata JWT is equal to os.getEnv, and I believe mine is just JWT lowercase. And then for the Algod client, we're going to need the token and the server. As we named them here. And then we can instantiate our client here and pass in positionally our token and our server. So Algod token, Algod server. And then we can also instantiate up here our Pinata client. Pinata client is equal to Pinata, all uppercase. And we're going to use the parameters here. So API key is equal to Pinata API key. The secret key is equal to Pinata API secret. And the JWT, or access token, is going to be equal to Pinata JWT. Now we have a Pinata client to upload our images, and then an Algod client to communicate with the Algorand network. And now we're going to get an image for us to upload to Pinata, Charmander PNG. And then pick our favorite one. This one looks fine. And save the image. And I'll just name it Charmander. And then we're going to drag and drop this into our Visual Studio environment here. Where's the folder? Here. Perfect. And then we're going to define the path for this file. So image path is going to be, it's within this directory. So ./Charmander, and this is a .png. And this is pretty simple with the Pinata client. So the response and the hash that we get is going to be Pinata client dot pin file and pass in our image path. And then the hash that we get, we'll print the response quickly so we can see what it looks like. There we go. We get a dictionary, status success, data, and the IPFS hash here, pin size and timestamp we won't be using. So we're going to state here using key notation that our image IPFS hash is equal to response, access the data key, and then access the IPFS hash key. And if you wanted to have an URL, so IPFS URL is going to be, we'll create an F string IPFS colon //, and then we can use curly brackets here and pass in the image IPFS hash. And this is what we will include in the URL field of the asset configuration transaction. If you wanted a viewable hash, which you can paste into your browser, it would be https://gateway.pinata.cloud/IPFS /+ image IPFS hash. We can concatenate these here. And we can print this image IPFS hash. And we'll put in the image path as well. Why not? And now we're going to run this so we can confirm our image is uploaded. Oh, I meant to print viewable hash. And we can hold Control and click this link. That's fine, open. And we'll see our image here uploaded to Pinata. So now we're going to define metadata. And this is going to be a dictionary. And for the ARC69 standard, the first thing you define is the key standard. And this is going to be the standard, which is ARC69. MIME type is next. And we're going to set this as the type of the image. So it's going to be image/PNG. Then we define our properties. And these are the details about the Pokemon that you want to set here for your NFT. And this is going to be another dictionary. So in here, I'm just going to input type. And this is going to be fire for Charmander. Description. And I will say a fire Pokemon with a fiery tail. And then we're also going to give him a level. So we'll say level 1. And then experience will be set to 0. And then that's pretty much it for metadata. And we can start creating our asset configuration transaction. So for the asset config transaction, we already imported here the asset configuration transaction. So we're just going to create an instance here and start defining all of these variables here, all these parameters. So the sender is going to be our address, which we need to get at the top here. So private key is equal to, an address is equal to. Let's actually generate an account. So get account.py from algosdk.account, import generate account, private key, address is equal to, generate account. And then we can print our private key and address. Then in our .env, we'll create a key. Private key is equal to, and this is relative to the Algorand account. And then we can take our address and go to bank.testnet.algorand.network, paste in our address, and fund it with testnet algo. If by chance you already have an account that you want to mint with, because I'm sure someone here is like, oh, I want to mint from this specific account, what you can do from algosdk.mnemonic, import to private key, I believe. Let's see. Returns the private key for the mnemonic. So what you would do here is you would type in your mnemonic phrase. So test, word, sentence, flights, whatever it has as your mnemonic. And you would do that for all the words here. Once that's filled up, so I only put 4 words in here, but you should have 25 words to input. Once that's done, private key is equal to private key, and you would pass in the mnemonic phrase and print the private key. So this is if you're on mainnet and you already have a account that you want to use to generate the NFTs, you would use this here. Input your mnemonic there, convert your mnemonic to a private key, print the private key, and then you would paste that into your env. I'm just going to use a random testnet account. Okay. We don't need an account anymore. And then we funded here, so status code 200, success, so we're good to go. os.getEnv, private key. And then our address is going to be address from private key, pass in our private key. An address from private key is from this library here, algosdk.account. And our sender here, we can now define as our address. We also need params, suggested params, and we can get this directly before. So params is equal to, and we fetch this from our Algod client instance, suggested params. And after this, we need an index. So since we're creating the asset for the first time, we don't have an asset ID. So we're going to leave this blank and basically just not include it at all. We're going to mint only 1. And we're also going to set decimals to 0 because we don't want this NFT to be able to be fractionalized. It will either be 1 or none when transferring. Default frozen is going to be false because we don't want it to be frozen on creation. And then manager is equal to our address. Reserve is equal to our address. We won't have a freeze or clawback. Asset name is going to be test Charmander. The asset units or unit name, let's just fix this here. The unit name will just be TC number 1, why not? And we will also need the URL that we just generated, which is going to be not this viewable hash. We're going to use this IPFS URL. Or actually, we're going to use the viewable hash. I've noticed that when I use the default IPFS link, and I don't even know why I'm doing this here, it actually doesn't load the image. So I'm not going to use that. I'm going to use the Pinata link here. And after this, it's going to want a strict empty address check because we're not including a clawback or freeze address. And then the note field is where we're going to place our metadata. And this is why we have JSON imported. So we're going to type JSON.dumps, our metadata, and we're going to encode this into bytes. And that's it. For the asset configuration transaction, now we want to sign it. I'm going to use shorthand signed AC transaction is equal to asset config transaction dot sign and pass in our private key. And then the transaction ID is going to be the result of sending the transaction, which is a method of our Algod client, and pass in the signed asset creation transaction or asset config. Print the transaction ID. We're going to wait for the transaction to be confirmed, even though it's final, because we need the information that comes with its confirmation, which is the asset index. Pass in our Algod client and the transaction ID, and the transaction info is equal to Algod client pending transaction info, even though it's going to be completed, and we pass in the transaction ID and print transaction info. And let's run this code. And we get this print statement for the image path, IPFS link, the transaction ID here. And then this is the transaction information here. And you'll see it comes with the asset index up here. I only want the asset index, so I'm going to change this to asset index and use key notation at the end here to access asset index in the dictionary and print that in the future so we don't get this whole mess. And if we go to para, the testnet para, because we're using testnet, and view our test charm editor, you'll see the image here, the name we chose, the unit name, manager and reserve address, freeze and clawback is not set, and the metadata is down here. And you can see the properties, fire, level, experience, and description. Now, if we wanted to adjust the metadata or change these properties, go back to our code here, we would simply submit a second asset configuration transaction with the bare minimum information, and this time include the new metadata in the node field. I can basically copy and paste this, and I will not need to declare the total anymore because that's immutable. Decimals, immutable. Default frozen, immutable. Manager and reserve have to stay. If you don't indicate them here, they will be set to none. So you will lose the manager and reserve address for this asset. The asset name, we can't change. Unit name, we cannot change. URL, we cannot change. This is the image. We don't need actually we still need the strict empty address check. And we need to add the index now that we have it. And this will be equal to the asset index that we generate. So in the future, if you already have an asset index, what I'm doing here is I'm creating the asset, getting the ID, and instantly changing it. You would just input the asset index manually if you were doing this separately. So I'm going to pass all this in, just double check, we're good. And we're just going to submit this now. So signed asset config transaction is equal to, and we can just copy and paste all of this, to be honest. Where is it? Here. And we don't need the asset index, since we're already going to have that. And we don't need to wait for confirmation. And I just realized we didn't create new metadata. So we're going to go down here and change the metadata. So let's say level 4 and 15 experience. And run this code again. So we're uploading to IPFS through Pinata, defining metadata, defining the asset parameters with the metadata, submitting the transaction, getting the transaction ID, getting the asset index or the asset ID, defining new metadata, creating another asset config transaction with a new metadata, signing and submitting. And here we have the asset index, and we can check here that we have a Pokemon. And let me actually run this one more time so I can quickly show you before it changes. Okay, so as of now, level 1 experience 0, but if I refresh, the second transaction should have went through, and now you see level and experience is now 15. And that's pretty much it for ARC69. And the next video we'll go over ARC19.